So this video is going to have some optional consolidation or checking work that you've already done. Make sure you are trying the questions before I show you the answers. Pause the videos as you need to. Otherwise, you're just watching me do the maths, which you're losing out on practice if you do that. So start from question 7. You can see that this is a rotation of the shape. I can see it's been rotated 90 degrees clockwise or 270 degrees anti-clockwise. The center of origin, center of rotation, you have to work out using a bit of tracing paper. Hopefully you figured out through a bit of trial and error, it's probably going to be somewhere around here. And I can see actually I was right, it was going to be about the origin or 0, 0, and we can just show that on the tracing paper. It's going to be 90 degrees clockwise. Okay, question 8. Describe the single transformation from A to B. This also does look like it's been potentially rotated or reflected. So let's see. This looks like we have a reflection. So let's look at the ray lines or the mirror lines. We're going from A to B. Now, if we go halfway along, all of them should line up if the shape's been reflected. So we can see how many diagonals is this? 1, 2, 3, 4, 5, 6, 7, 8. So if I go 4 diagonals up, and this is going to be 4, so that's 2. This is also going to be 1, 2, 3, 4, 5, 6, 7. So I'm going to use to go 3.5, and actually that does work out. So this is your mirror line, and you can see the equation of that line is y equals x. So shape A has been reflected on the line y equals x. Okay, question 9. This time it's clearly an enlargement from A to B. So it's going to be a fractional enlargement. It's a fraction between 0 and 1. We need to draw our ray lines for the corresponding points of this shape here. So I can see already this is looking like, I'm going to have to try that one again, maybe it wasn't accurate. So I can see it's going to look like it crosses here. And it looks like we found our center of enlargement, which is 311. This scale factor, well, we're going from the black shape to the reddish purple shape. So you can see it's the side length 2 becomes side length 1, so the scale factor is a half. So it's an enlargement, scale factor half, about the point 311. So remember to have all those points shown. Question 10. Describe the single transformation from A to B. So going from A to B, this is going to be a translation. So we're going to go left and right first to the corresponding vertices here. So we can see we've gone 1, 2, 3, 4, 5. 1, 2, 3, 4. So positive 5, negative 4 is your vector. Question 11. Describe the single transformation from A to B. So this is going to be a rotation. You will have to use some tracing paper to work out the center of rotation, which will be somewhere around here, I'm guessing. Indeed, it's actually down there. So it's negative 1, 1. And you're going to have to rotate it 90 degrees anti-clockwise to go from A to B. Okay, question 12. Describe the single transformation. It's clearly an enlargement, so going from A to B. So we can draw our ray lines. I'm thinking it's going to center of enlargement is going to be somewhere here. So let's see. And we can see from that it's looking like we're right. It's going to be 11, 1. So your center of enlargement. Now the scale factor, to go from A to B, the arrow should really be pointing the other way. We can see that the side length is 2 and it becomes 6. So the scale factor is 3. Center of enlargement is 11, 1. And it is an enlargement as well. So that's question 12. For question 13, this is a nice simple one. Find a corresponding vertex, and you can see we've been shifted 1, 2, 3, 4, 5 units to the left. So it's -5 over 0. Question 14, single transformation from A to B. So we're going from A to B. So it's again an enlargement. So let's find our center of enlargement. I'm thinking it's going to be there, and we'd be right. So since we're going from A to B, it's shrunk, so it's a fraction between 0 and 1. The side length here is 1, 2, 3, 4, 5, 6, and the side length here is 2. So from 6 to 2. The scale factor is 1/3. Center of enlargement is 11, 9. This is a question 15. So we can see that the shape, if we were to rotate it, this side would have to be on the right. So it's not a rotation, it's going to be a reflection. So what we need to do is find the mirror line here. So let's just connect the corresponding vertices and go halfway along, and I think we can see what the line is here. So 1, 2, 3, 4, 5, 6, 7 diagonals, so 3.5. 1, 2, 3, and 3.5 is halfway. This, the middle is there, and then the middle of this line is here. So we can see the mirror line is y equals -x. It's reflected on the line y equals -x. Question 16. Describe the single transformation from A to B. So again, we'll draw some ray lines and we can figure out where they meet. I think it's going to be down there. It looks like we have it. So our center of enlargement is here, and we're going from A to B. So the side length 2 becomes side length 4. Scale factor is 2. Center of enlargement is 9, 11. Question 17. Describe the transformation from A to B. So this is looking like a rotation. So use some tracing paper. Your rotation, center of rotation, probably somewhere here would be sensible to try. And you can see it happens to be around the origin. We're going to rotate it clockwise. Okay. Question 18, this is the last question. We're going to practice. So it says describe, we're going to go from A to B, describe the transformation. So let's draw some ray lines and see where they meet. It's looking like we found our center of enlargement. Now if we're going from A to B, you can see the shape B is twice as big because the side length 1 becomes side length 2. So scale factor 2, center of enlargement 10, 3. And there is your answer. So hopefully that was useful. Describing transformations is fairly straightforward if you know the methods that you need to do this. So drawing ray lines, drawing mirror lines, finding the center of rotation using tracing paper, and of course translations, which are really straightforward. You just find corresponding vertices and figure out how they've shifted. So that is transformations of shapes. Hopefully you found that useful. I'll continue later.